Hello and welcome to this video on elements and the periodic table. Now a very good question is, what is the periodic table? Well, the periodic table is an arrangement of all the elements that have been discovered so far. Now there may be one or two more yet to be discovered, but we think we've actually found most of them. But if you go back in time, back in history, the early 1800s, elements were arranged at that point by increasing atomic mass. So lightest elements first and increasing atomic mass. Now when this was done, there seemed to be some sort of pattern, a periodic pattern was noticed in the properties of the elements. They seemed to be similar in certain groupings. However, at this point, early periodic tables were not complete, and some elements were placed in the wrong group. Some elements at this point hadn't even been discovered, and so no one left gaps for these to be slotted in. This was a result of elements being ordered by relative atomic mass, and the properties of them were not taken into account at all. Now this gentleman here changed everything. This is a Russian scientist called Dmitry Mendeleev, and he very carefully produced one of the first practical periodic tables in the 19th century. Now he did some important things to make sure it worked. So Mendeleev produced a periodic table based on the following ideas. 1. Elements are arranged in order of increasing atomic number, not atomic mass. 2. The horizontal rows are called periods. 3. The vertical columns are called groups. And 4. Elements in the same group, that's the vertical columns, are similar to each other. Another big thing that Mendeleev did, he left gaps in the periodic table for those elements that hadn't been discovered. And amazingly, when we did discover these elements, they fitted his pattern perfectly. So here we have a classic modern periodic table. Now we have what are called groups. So groups 1, 2, 3, 4, 5, 6, 7, 0. Some books, some periodic tables will have the end column as group 8. Here it says 0. Okay, so we have vertical columns called groups. Now some of those columns have familiar names. For example, over here, group 1, these are known as the alkaline metals. Now notice we've got hydrogen here. Hang about, hydrogen's not a metal. And similarly, we've got helium over here. Now hydrogen and helium sometimes are put separately in the middle here, away from everything else. Group 2, we've got the alkaline earth metals. Then this big block in the middle are called the transition metals. Then over here, we've got group 7 are the halogens. Group 8 are called the inert gases, or rare gases, or noble gases. Inert means they're unreactive, so let's stick to the word inert, shall we? And down here you've got lanthanides and actinides, which we're not bothered with at all at our stage. Okay? Now, as well as groups, going across, we've got what are called periods. The periods are the horizontal rows. So we've got period 1, that's just got in it hydrogen, helium. Period 2, lithium to neon. Then period 3, sodium to argon. Period 4, potassium, krypton, and so on. So those are the periods. Notice also we've got this really important distinction here. Now metals to the left of this bold line, as you can see here, metals to the left, non-metals to the right. So any element to the left of that bold line is a metal. Any element to the right of that bold line is a non-metal. Now, elements, thankfully because of Mendeleev, are laid out in order of increasing atomic number. So we can see, here we've got hydrogen, number 1. And that goes all the way down here to lawrencium, which is 103. So they are arranged in order of increasing atomic number, also known as a proton number, because it tells you how many protons are in the nucleus. So for example, let's pick on sodium. Sodium has got atomic number of 11, which means it has 11 protons in the nucleus. Really useful to know that. So group number tells you how many electrons there are in the outer shell. Group 1 elements all have 1 electron outer shell. Group 7 electrons, for example, all have 7 electrons outer shell. And group 8 elements all have 8 electrons outer shell. They're full. They have no more room outer shell. Elements in the same group have similar properties. So we can think about that in terms of properties of one element in the group. You can then predict properties of all the other elements. Group 1 elements, for example, all have similar properties. They are soft, shiny metals, and they all react with water. The layout of the table also enables us to make predictions about trends in reactivity. If we look at group 1, for example, now these react with water. Let's ignore at the moment hydrogen. Okay, we're going lithium, sodium, potassium, rubidium, cesium, francium. Now all of those react with water. Lithium, which is here, lithium will just sort of fizz a little bit with water. Potassium might react quite vigorously with water and burst into flames. But coming down to francium, now francium is highly reactive with water. When francium reacts with water, there'll be a huge explosion. You wouldn't want to get in the way of it. Now, over in group 7, it's the other way around. Elements react less vigorously down the group. So in that one there, we've got fluorine at the top. Fluorine is the most reactive element in group 7. Okay? Now the period number tells you how many electrons or electron shells are around the nucleus. So for example, what have we got? Well, period 2 tells you 2 shells. Period 3 tells you 3 shells. Period 4 and so on. So for example, period 3, which is coming along here now, all of these have 3 electron shells or orbits. Pick on magnesium. Magnesium has got 2, 8, 2. 2 electrons in the innermost orbit, 8 electrons full next orbit, and 2 in the outermost orbit. A quick glance at the periodic table would tell us a lot about any specific element. So for example, let's pick on sulfur. Sulfur's here. Now sulfur is in group 6, 6 electrons out of shell. It's in period 3, 3 orbits outside the nucleus. So we now know that the electron structure around the nucleus in sulfur is 2, 8, 6. Okay, well that's it for elements in the periodic table. Hope you enjoyed the video and I look forward to joining you again very soon. So bye bye for now.